Hello again, this is Mr. Richens, and welcome back to another lesson in chemistry. We're continuing Unit 2, discussion of atomic theory, and in this lesson number 4, we're going to talk about how chemists describe and differentiate between different types of atoms belonging to different elements. In reading section 3 of chapter 3, you have encountered a couple of terms which I want to review with you. The first is the atomic number, which is equivalent to the number of protons in the nucleus of an atom. And if you remember, it's the number of protons that distinguish one type of atom from another, one element from another. And so all atoms of the element helium have an atomic number of 2. All atoms of the element gallium have an atomic number of 31. We can find the atomic number on the periodic table, and it's typically located at the top of each entry. And so here we see it. Boron has an atomic number of 5, carbon 6, nitrogen 7, and so on. Bismuth 83. Your periodic table will be an essential tool in your success in chemistry. In addition to the atomic number, which is the sum of the number of protons and the number of neutrons in the nucleus of an atom, these together are called the nucleons. The atomic number is symbolized with a letter Z, and the mass number is symbolized with the letter A. Now the mass number is important because each element can consist of 2 or more different isotopes. Since they're atoms of the same element, they all have the same number of protons, but they can differ in the number of neutrons they contain. That's what distinguishes one isotope from another. So for instance, if we take a look at this table of isotopic masses and natural abundances, we can see that hydrogen has 3 isotopes. Hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 2 is also known as deuterium. Hydrogen 3 is also known as tritium. If we look over here, we can see that calcium has 6 commonly occurring isotopes. Calcium 40, calcium 42, 43, 44, 46, and 48. All these atoms have the same number of protons in their nucleus, but they differ in the number of neutrons that they contain. If we look a little bit closer at the isotopes of hydrogen, here we've had hydrogen 1, deuterium or hydrogen 2, hydrogen 3 or tritium. All of them have the same atomic number. It's equal to 1, which means that they all have 1 proton in their nucleus. But they differ in their mass numbers. And in fact, that tells us that hydrogen 1 has no neutrons in its nucleus, hydrogen 2 has 1 neutron in its nucleus, and hydrogen 3 has 2 neutrons in its nucleus. That means that the mass numbers for these 3 isotopes are respectively 1, 2, and 3. Putting the mass number as a superscript preceding the element is standard notation in chemistry. And so if we were to be given this example, magnesium 24, we know since it's magnesium, and if we find magnesium on our periodic table, we can see that it has atomic number of 12. So we know that Z is equal to 12 and the mass number is equal to 24. So that means there must be in the nucleus there must be in the nucleus 12 protons and 12 neutrons, so that when they're added together you get a total of 24. So how do we figure that all out, you might be asking? Well, there's a couple of easy formulas that you can keep in mind, and really if you understand the concepts very well, the formulas will just occur to you. So Z, the atomic number, is equal to the number of protons, and A, the mass number, is equal to the number of protons plus the number of neutrons. So those together imply that A the mass number, is equal to Z, the atomic number, plus the number of neutrons. That information, the atomic number, will be available off the periodic table. The mass number should be given to you in the problem, depending upon the type of problem. I could give you the number of neutrons and ask you to find the mass number from the number of neutrons, but it would involve this equation right here. So if we rearrange this, the number of neutrons is always going to be equal to the mass number minus the atomic number. So let's take an example. I'm going to go to my table of isotopes and let's look at vanadium 51. Vanadium 51 right here, and we have the atomic number 23 for vanadium. It's at the column labeled Z. So we've got vanadium 51. We know that Z is equal to 23. The number of neutrons that are contained in the nucleus will be the mass number 51 minus the atomic number 23, and so that's going to be equal to 28 neutrons in the nucleus of the vanadium 51 atom. Atoms can become ions by gaining or losing electrons. If an atom gains electrons, then its charge is less than 0. It has more negative charge than positive charge, more electrons than protons. If an atom loses electrons, the charge is greater than 0. It now has more positive charge than negative charge. Now remember, it's important that ions are the result of the loss or gain of electrons. The number of protons can't change. The charge of an atom isn't affected by gaining or losing protons. In fact, that can't happen. If we gain or lose protons, then we actually change to a different element. Ions are formed only through gains or losses of electrons. We can find the charge by calculating the difference between the number of protons and number of electrons. So we put the number of protons first, we subtract from it the number of electrons, and that will give our charge the proper sign. If we have more protons than electrons, this number will be positive. If we have more electrons than protons, this number will be negative. Let's next consider an example of the type of problem you would be asked to do with this. So let's consider sulfur 34 2- ion. So the atomic number for sulfur is 16. So our atomic number is 16. Our mass number is 34. And our charge is 2-, or you can think of it as -2, but it's written with the sign after the number. So our number of protons is equal to the atomic number, 16. Our number of neutrons is equal to the difference between the mass number and the atomic number. So in this case, we'll have 18 neutrons. The number of electrons can be found by looking at the charge, realizing that it's 2-, so that means there are 2 more electrons than protons, so the number of electrons must be equal to 18 also. That wraps up today's lesson. Join me next time when we'll continue talking about the numbers involved in atoms. Bye.